So during this talk, I'm going to tell you a little bit about myself, my background, where I came from, how I got to be a project manager, a little bit about why we undertake track renewals, the process and procedures that we have to follow as a delivery outfit, going into things like standards, design, all that kind of stuff. Point 4 touches on problems that we can encounter. There's an example, believe it or not, on drainage, which you mentioned, which is coming up in one of the renewals I'm going to be delivering next year, but it's worth pointing out. And obviously, example of the track renewal that I undertook recently at Easter, which is based at Great West Junction. So in terms of me, I'm an ex-Network Rail track apprentice from 2007. I worked out the Havant depot for 3 years within the permanent way team. I moved into track access planning after my apprenticeship at Eastleigh DU, working with the work plan coordinator and track access coordinator for around about a year and a half. Then I moved into track renewals under the RT24 contract, working with Balfour Beatty as a Network Rail project management assistant. Worked my way from PMA to scheme project manager. I then left the Eastleigh renewals team and joined the initial S&C alliance prior to the Rail Systems Alliance I'm in now, because there's been 2. And I worked from scheme project manager to my current position as project manager for Wessex S&C and Plain Line, and then moved over to the South Rail Systems Alliance that I'm in now. I've delivered well over 100 track renewals. S&C Plain Line, I've done a lot of enhancement work as well. And as well as delivering day-to-day renewals, long-term plan stuff, I've also been part of recovery projects such as Eastleigh derailments, and I was the project manager for the Fisherton Rail disaster in 2021. So that's a little bit about me. This just demonstrates the companies that we work with as part of the Rail Systems Alliance. So we're in alliance with Colas Rail as our delivery contractor, project management being based around Network Rail, being myself, and ACOM are our design partner. So it's a sort of widespread alliance. We've got every utility we could possibly need within that alliance to deliver the track renewals that we need to deliver. This has been the sort of stalwart for CP6. This has always been about. We've been in it for 5 years, and going into CP7, we actually changed to, as Paul mentioned, the Southern Renewals and Enterprise. So we lose Colas and we go to work with Volker Rail. So Volker Rail have been awarded the contract for the track delivery. At the moment, we're in a bit of a transitional period with them. Some good bits, some bad bits, but you're going to get that when you get a contract changeover anyway. There's sort of changes in personnel, whether the people that work there currently want to stay there, whether they're going to 2P. So it's all a bit of a juggle at the moment. We're just trying to make things work and continue delivering as much as we can at the moment. So that comes into fruition in April next year, the new financial year. Colas deliver up to week 4, then come week 5, Volker walk in and take the reins and start delivering the renewals that we do currently. So we shouldn't see much change. It should be a smooth transition across with all the work that we're doing behind the scenes with disposition statements in terms of projects that we've got currently going on, any kind of remaining works. We're just identifying that with sort of the 50 or 60 projects that we've got sort of within the 3 routes currently rolling and up to the end of the financial year. So while we undertake renewals, this isn't exhaustive. This is just a few reasons. So there could be component issues, historical issues with the actual assemblies themselves, changing operational requirements and standards, formation issues, bring the asset up to modern equivalent format. So if new technology gets introduced and everybody wants it in because they want a betterment in terms of operations, obviously putting passengers first is a big thing for us. Every minute counts. We get crucified for any kind of delays, or if there's any issues, then we're held to account for it. As some of the guys in this room know, I recognise some faces. It's a hot topic, so we try to do the best we can with what we got to make it a nice new shiny railway. As well as that, the track renewal can take anywhere between 12 and 36 months from concept to delivery in terms of its life cycle. It all depends on the urgency and the outlined requirements. So as we currently sit at the moment, on delivery, but before me, there's a development team. So they'll get hold of the project initially from the problem statement. So once our asset engineers turn around and say, "Well, we want that done," they'll turn around and say, "Right, okay, no problem. Let's work out the requirements for the projects." They'll develop it, and around about TT84 from deployment, that's when I take the reins into delivery. So they're in the new world. It's called PACE. So they're effectively PACE 1, and I'm in the world of PACE 2, 3, and 4, which my realm covers development, delivery, and handback. So that's what I do in terms of my role. Track renewals are arranged into years within a control period, and they can also be deferred and moved. I mean, Paul used to be the track round in Wessex, so Paul knows this all too well, sort of working out where they're going to fit, how long's the asset going to last, do we need to do it earlier, can we move it around, is there funding available for the work that wants to move in the control period as well. So that's always a big thing for us, to nailing down a work bank. And the other one is obviously the maintainability is causing an issue. Big one, Basingstoke, Great West Junction, historically absolute nightmare to maintain. Countless failures, as you alluded to, with the RT60. It was awful. It was just an awful setup from the day it went in until myself and my team went in and actually delivered what's there today. So that's a little bit about why we undertake track renewals. Processes and procedures we have to follow. This list is non-exhaustive as well. There's a lot of red tape that we have to jump over, get through, just in order for us to be able to deliver a track renewal. So 02009, that's all about engineering. So that's accountabilities, identifying roles and responsibilities, managing non-compliances and all that kind of good stuff. PACE, as I alluded to, is the new grip for track. That's the process that we as the deliverer have to abide by. And you'll notice there's phase gates, which at the end of every PACE stage, we'll have to go through a stage gate. So within my world, it's T42, T21, T4. And then once we hand the job back and the final cert's been issued, we go to something called a T+8, which is all records returned, which obviously records are faster. So it's a hot topic for us at the moment. So that's PACE and phase gates. CDM 2015, construction design management. We have to buy that. It groups together all the legislation and everything. That's something that we have to follow as a principal contractor, as a delivery mechanism. DCI's design construction interface meeting. This is where we get into the down and dirty of the designs. So we'll have our engineers sat together, project management, construction. We'll talk about what's been designed, what we think could be improved. Does it work? Does it fit? And then we develop the design through those sessions. Funnily enough, today was DCI day in Tunbridge, where I came from before I came in. So sort of a full day sitting in a room with a load of engineers working out. Yeah, it's good. We're happy. Then we go from there. AMP is the asset management plan and health and safety files. This forms part of CDN 2015. Obviously, we have to be able to provide the asset owner with a record to say that what we've installed is fit for purpose. So within the AMP process itself, there's 17 documents that we issue, and we request that signatures are provided from the asset owner to make sure that they're happy. On top of that, there's other bits and pieces like designs we have to give them. We have to give them track geometry acceptance certificates to say the track geometry is good. So that's scored for us. Trying to think what else we give you as well. That process is mandated. We have to follow it. There's no way of getting around it. We have to. It's a regulation or like a procedure that's put in place to say that asset is completely fine. We can take it back. There's no more work for the delivery team. Off to maintenance it goes. We have to abide to 2102 and 2049. So those are two standards that we live by in terms of track renewals. 2102 is the track construction standard, and 2049 is the S&C design standard. So doing what I do, those are the two big standards for me. And off the back of that, once we've actually physically delivered the track renewal itself, I have to do something called entry into service, which Graham knows the guy that I deal with. Is a guy called Pat Butler. He's the senior test and commissioning engineer for the route. So anytime I've got any works, I have to sit with Pat on the hand back, go through what deliverables he wants to prove that what I've delivered is fit for purpose, and he has to sign off on it. So it's an extra step to make sure that what we're delivering abides by every process procedure standard. It's all fit for purpose. There's no problems, and it does what it's meant to do. Approval process for designs, that's with the engineers and obviously the route team. So we'll submit a design to the asset engineers. We'll have reviews. They'll make comment. If they make comment, we have cap 1, 2, and 3 that we go through. So that's a classification of how good the design is. They make comment on it. We go back, we revise the design. We go back again, we have a further review, but on top of that, we have RDCs, which are interdisciplinary checks, and IDRs, which are interdisciplinary reviews as well. So all forms part and parcel of sort of getting the design from outline design to accepted for construction. Usually it can take a long time. I mean, Basingstoke took 70 weeks to get from the outline design to the actual accepted for construction design that we delivered and put in the ground. DWWP is delivering work within possessions. This is another sort of network route process that I have to abide to. It's things like doing quantitative risk assessments with risk analysts to make sure that my project plan, which is like the Gantt chart, the bar chart, which shows you the timings of the project, to make sure it all fits in with the planned time that's there available. So it's done through a system called Perk Master. We call it the Monte Carlo system because it's a bit of a roulette because you don't know whether it's going to go through or it's not. So we have to give mins, maxes, and most likely times against each of the activities within the bar chart, and it goes through 10,000 iterations of different scenarios based on those times, and it spits out a result. So if we have to abide by P90, so we have to be 90% certain that the plan that we're putting in the table and the plan that we're walking into the 52-hour possession or the 9-day blockade, we're going to hand back on time for the end user. We have to have 90% confidence rate that we can deliver it within that time. If it doesn't, then obviously we have to go back and rethink it and try and work out where we can put other bits and pieces and see what we have to sacrifice, take out, put to follow up. Summit reviews, Paul, you've been a part of these as well. We sit with Mike Sowden. I don't know whether anybody knows Mike. So we sit with Mike, get hammered.
Apologies, but
well, I had a few emails from Mike about it. He was a little bit gutted he couldn't be here to give me a hard time. But so yeah, we all sit in a room together. So when we have a possession, it's not just one piece of work that's going on. We try to make it as efficient as possible, try and get as much done as we can with at least disruption to the passenger as we can. Sometimes it works, sometimes it doesn't, but we do try to make the most of it. Especially if we get blockades, like we've got a 9-day block coming up at Petersfield, Farnborough to Petersfield for resignaling. It's absolutely jam-packed. And Basingstoke, although it was only 4 days, it was absolutely rammed full of work, and we had to make sure that all of it worked and we could still deliver the S&C renewal itself as well. That's an all-day session. It's quite hot and heated. You walk out and they're basically crawling. So, but yeah, that's another one. And also we have to follow discipline-specific standards. So to civils, to track, to S&T, to electrification, all of those get brought into the trap and all the design phase, make sure we're doing it. If there's any non-compliance, we try to iron them out, try to get rid of them as part of the design. So instead of being existing, they're forgotten. So we always try to improve on what we're doing. But like I said, this is just to name a few. There's a lot of red tape. It takes up a lot of time to get through all of this. Me personally, I've got me and a scheme project manager. So I've got me and one other that deliver the S&C renewals on Wessex alongside our engineering team as well. And our construction team is pretty busy, pretty frantic. You know all too well, Paul. We're at it constantly, delivering every single weekend when we've got work. But yeah, that's just to name a few of the processes we go through. Problems we encounter as a delivery organisation. Again, this is non-exhaustive. There are more. Lack of experience can be a real problem for us. So anybody that it's more in relation to sort of resources and stuff like that. So if we get you get your blue hats on site and stuff like that, that can be quite challenging trying to bring them up to speed if it's their first shift on a renewal. It's kind of like getting them into the working methodologies. They could be working with a maintenance team. All of a sudden, they're walking onto a plain long renewal that's 1,000 yards, and they're looking at it, and they're like a rabbit in headlights. So lack of experience does come to it. Funding is a big thing as well, as I touched on earlier. Sometimes there's money to do it, sometimes there's not. So when we get a scope of work sent over, we're saying, well, we can afford that, but we can't afford that. What do we sacrifice to make sure that happens? And off the back of that as well, I mean, we could have the requirements set through from our asset engineers and from the route, but sometimes they change. So if we discover something while we're designing, we'll send in a technical query with a cost attached to it. For example, I did Worthing Junction after Basingstoke, and we ended up with an extra £130,000 worth of power works we had to do that wasn't accounted for in the specification. So what they had requested required us to upgrade this D&O. So it cost us an extra £130,000, which is obviously no small feat and no small cost to anybody, especially to the taxpayer. But we couldn't deliver what the actual physical outline requirements of the project were without doing it. Maintenance. Yeah, maintenance can be a bit of a problem for us as well. So we can go out and survey and site, and they could do something like go tamp our datum road. So then we have to go back out and resurvey it, or maintenance will come in after we've delivered a renewal, and where we set assemblies up to construction standards 2102, the maintenance standards for say a switch are completely different to what ours are, and they'll go in banging shims in or something like that. And we're just like, well, you can't do that because it's part of the AMP process. If you step in and do anything before we've handed it back, it's called a TOC, taken over cert. So until we've given you that, you can't touch the asset. It's under our ownership. But we have countless times where this happens. Not through fault. We could have a failure that could mean that they have to do it. But it's all about breakdown in comms and who's responsible. But yes, just to touch on two, they're two of the big things for us. Tamping the data row is probably the worst one because we spend 4 to 6 weeks out there surveying, and someone comes through with a tamper, just tamps it. So you can imagine how much trouble it causes us. Assembly's not being approved. So in relation to S&C, so technical authority have to approve the layout for us to be able to deliver it. So at Worthing, it was requested that I install a SGV switch, SGV crossover with hard drive. It wasn't approved. So we had to go back through and do a load of integration testing with Alstom. So we had to go and buy a new crossover, get Alstom out and work out where they put the SO units for the hard drive. And then we had to get it approved by TA. But it was only because we looked at the standard and said, well, that's not approved, so what do we do? And that costs a lot of extra money as well. I think that costs an extra £100,000 to do it. But that's no fault of anybody's. It's just something that, while the new technology being sort of brought in and integrated into like the working world as we see it now, it just got missed because we don't install that many SGs as a business anyway, especially on Wessex Road. That I can only think of a couple of locations where they are. So that's that as well. Pre-construction information can be poor, mainly in relation to records. So you could have other projects working on the same footprint of grounds, say a year beforehand. They've undertaken the work, but they haven't updated the records. So when they get sent back to the National Records Group, we're working off the old records, and we're like, well, it doesn't match. So we have to go through all of that as well. A lot of the time, it's in relation to drainage and signalling. Drainage being the worst. It's a nightmare. But yeah, so the pre-construction information be poor, which means we have to take all of the fact finding into the actual development and delivery itself. So we're still sort of learning ourselves as we go through the natural process of development. Resources, we could have a really busy weekend on the route where you've got 4 track renewals. You've only got a finite amount of engineering trains and wagons. You have to try and think outside the box. So an example of being at Basingstoke Great West Junction, we had Reading S&C on, and we had a couple of S&C jobs over in Kent, Sussex. There were no Tilton wagons. So the Tilton wagons are the wagons. I don't know if you've seen them, but they sort of they arrive tilted and they come down hydraulically with the S&C on it. So we didn't have any of those. So we had to think outside the box. We had to have all of the S&C delivered and stacked up in a siding prior to the works. So then the Kirov came in and took it. Kirov came in. We had no wagons. It was already there, ready to run, and we just run the panels from the siding. So it's cheaper as well to do it that way. Believe it or not, if we use a set of Tilton wagons, it's around about 50 grand. It's a lot of money once everybody's had their little piece of the pie. And if you get it pre-delivered, it kind of turns into about half the cost. So it's a big efficiency if you can do it as well. Again, touching on records, some places are good, some places are bad. Some companies are good at doing it, some contractors are bad at doing it. It all depends. It's a bit of pot luck, but following on from sort of the Carmel disaster that happened up in Scotland a few months ago and all that, the records is a massive thing now. There's like a real drive in network around to make sure that what's out there is recorded and it is actually physically what's on the ground. As a delivery unit within track renewals, we cannot hand back a site without making sure the records are updated. It's always been that way, especially for track renewals. So we're pretty squeaky clean. It takes time as well to do it. You're probably looking to update the records afterwards with the amount that we have to physically use, and especially for signalling, you're talking 4 or 5 months afterwards until they're all complete. And that all bodes on the designer for them to produce the records updates as well. So it's a big task to undertake anyway. Specifications, sometimes they're right, sometimes they're wrong. So we'll go out and ratify a project requirement specification or an RRD or a plain line spec. We'll go out and ratify it. We'll raise TQs against it to make sure what you're actually asking for is correct as well. So we delve a little bit into that. Existing non-compliances, big thing. We try to design them out. If we can't, then we have to manage it. We have to put them on trackers. They can be a right pain. I'll come to a slide in a minute. You'll see there I've got just a horrendous problem with an S&C renewal that I'm going to be delivering. Carrying optioneering into PACE 2. So PACE 2 obviously is my world into delivery. So we should never be optioneering once we get into development. So once it's handed over from the development team, that's signed, sealed, delivered. That is the approved for delivery option, approved single option. But sometimes we have to, because there's just where it's taken so long to develop it, we need to hand it over to the next team and just get run with it, because we'll never be able to deliver it otherwise. Basingstoke being an example, believe it or not, we had an issue with that. Access, obviously SWR and GWR and all those kind of people don't look at shutting the track to deliver the track renewals. So we have to get it right first time round, because if we go knocking again, we usually get told no. Funnily enough, I've got a job at Queenstown Road in year 2. So in 2 years' time, I've already had to put the access in for that because it's so disruptive. So as part of that track renewal, I need an all-line block outside of London Waterloo for 4 days. Really? To deliver. I've got it because we went at the right time and we said why. We stood in front of him, demonstrated it, showed him the plan, told him why we need X, Y, and Z lines. And believe it or not, the operators were we just said, well, yeah, fine. And we worked out, we give lines back at some points, but that's kind of the process we have to go through. Is we have a long-term planning manager and a short-term planning manager. They lean on our experience as well as the deliverers to sort of help them out with it. So they're looking at an engineering access statement 2 years out, and they'll come to us and say, does this work? And we'll say, well, no, this is what we need to do, change it. We have no end of problems with operators. Obviously, it's all about them being able to make money, service the passenger, and freight as well. Freight are a nightmare to deal with. For one reason or another, obviously they're there to make money. They need their paths. But we try to be as sort of non-disruptive as we can. Obviously, Queenstown Road, we're never going to be able to deliver out unless we do shut it, but that's one in a million. I don't think it's a really awkward place to work. CRTs and speeds in the summer, it's a big topic as well. Obviously, between March and the end of September, CRT season, so we have to be really careful about what we do. We usually try to hand back a track for nearly 50 mile an hour, unless there's a good reason for it. So I think over the summer, there was only one site that we had to reduce it because of the CRT, that we had to open the main line at 20 mile an hour, and think we're doing 40, 50 renewals a year. So it's not really that bad. It's disruptive. It causes delay minutes. We get a lot of really shouty people up in the ivory tower saying, why are you doing that? And we have to kind of prove to them why we're doing it. But yeah, it causes no end of headache, but it is what it is. We sort of adapt and overcome. We get used to it and we learn. We try to make things better. But that's kind of a few problems that we encounter in terms of an organisation. This just isn't exhaustive to renewals either. I mean, the whole of Network Rail face these problems in terms of every delivery team. It's sort of widespread across the entire industry. But yeah, those are just a few of the issues that we have. So coming on to the problem, I was talking about the non-compliance. So this is what I've got a situation at Millbrook at the moment on 542s. So I'm going to be delivering a setup coming out of a freight yard, Millbrook freight line terminal on the upside. 542s comes out onto the main line. It's 2-leveled at the moment. This precarious looking catch pit on the left-hand side is absolutely non-compliant. You can, I mean, look at the thickness of the chamber itself. It's 200 mil thick all round. And the image on the right-hand side shows you non-compliant arrangement in terms of sleeper to structure. So off the end of the base plate, it's supposed to have 150 mil, and then off the end of the sleeper, you've got to have 100 mil clearance between the structure. So we're trying to work out the bugs at the moment. I mean, I'm going there Sunday with a manufacturer that actually deals with drainage to see whether we can come up with a bespoke arrangement. They've had similar issues at King's Cross when they did the King's Cross project with the existing drainage. So we're hoping, fingers crossed, that the guy that's coming down can sort of wave his magic wand and say to us, well, we've got a solution for you, because otherwise we're in a bit of a sticky situation. But this is this is just one example of some of the things that we have to face in terms of an existing non-compliance and a sort of, I don't want to say poorly installed asset, because that's not fair. That's probably been there longer than the track. Nobody knows whose drainage system it is either. So you've got Association of British Ports sitting over one fence, and you've got the NR asset owner sitting on this side, and they're kind of butting heads and saying, well, it's not ours. But that's all down to records as well, because nobody knows whose asset it is. So that's one of the things that we have to deal with at the moment. But yeah, we're surveying this at the moment, trying to work out an option where we can go forward with it. And here we go on to Basingstoke Great West Junction. This project was a bit of a labour of love to me, to be honest with you. It was quite demanding from start to finish with everything that came with it. The image you see here is basically the finished product and what we installed. As part of the presentation, I'm going to take you through the scope of works for each of the disciplines and sort of show you other bits and pieces as well. So the image you see on the screen here is basically what we delivered as the delivery agent. So the blue is the S&C, the yellow is the associated renewal limits, the red is the additional re-rail limits, and additional renewal limits, and the grey box that you see just on the right hand side, the 18 yards is additional section of re-rail that we did as well. So you can see there we did the 2 fixed diamonds, 2 turnouts, and a bit of plain line that goes with it. Doesn't sound a lot, but it was a lot. It was a big ask in the time that we had to do it, considering everything else that went on with it as well. To track continue, this slide just basically goes into a bit of the scope of work. So we had 2 fixed diamonds in the NR60 Mark II arrangement. We had 2 NR60 Mark II turnouts as well. Diamond angles changed to 1 in 5 to 1 in from 1 in 4 to 1 in 5. That was to smooth the junction out. So that's what we did as well. We applied strapping rails as well. So as the train went around the junction, it didn't sort of kick out and sort of kept its gauge and didn't cause the junction to move. We had 284 yards of associated plain line, 83 yards of unassociated additional re-rail of 18 yards. There were no platform alterations as part of this packaging works. We do a lot of, if we're doing renewals, we do a lot of like Copra resets and tactile work as well, because we have to comply with standards. So the whole track moved by gauge towards the old signal box as well. So you think where it used to be, it moved by 1.5 meters towards the box, which opened up a can of worms in terms of drivers' walkways, civils works, and involving unions such as ASLEF to make sure that they were happy with what we were installing, which was it was a long drawn out process, but we got there in the end. So this goes into a little bit about the formation treatment. So originally it was a 1 in 30, but we reduced it to a 1 in 40 because once we got over to the up slow, it turned into an 1800 mil dig, which is just not deliverable. We just couldn't do it. The wagons weren't available. We would have been there probably 8 days instead of 4. We probably would have still been digging it after 8 days with that depth. So we installed GO and we installed sand as well, and we did ballast glue in here. It's a bit of a specialist sort of ballast gluing operation that went on at Basingstoke with a sort of new system. So we moved away from the usual Railtech stuff and we incorporated a system called Hurleman. So the yellow that you see there is the area that we actually ballast glued in place. So that's what we did. So ballast gluing. So this was undertaken post renewal. Obviously, we had to get the geometry correct before we started gluing it in place. We did it to increase the stability of the ballasting track. Again, Hurleman Railtech. So we actually glued 400 mil wide and 450 mil deep. So it's quite a lot of glue. We used 2,677 litres of resin for the entirety of the ballast gluing application. As part of it as well, it's really strange how we had to do it. So we had to keep the glue itself at 25 degrees for 4 hours beforehand, so it got to the correct viscosity. So those orange containers that you see in the photos there, those are sort of keeping the glue hot. It's a bit of a glue kettle. It was so. Yeah, so we did that. We contracted Romberg Sursa in to do the works. It was a huge cost. It was over £100,000 to do that. Yeah. And that was just the application itself. We already had the glue in stock. So the glue was supposed to be installed at Lewisham, but for whatever reason, it didn't go in. So we used the glue from Lewisham to put in Basingstoke. If we didn't, then that cost would have tripled. Hurleman Railtech glue is really, really expensive, but it's really good stuff. So yeah, we did that post renewal and it's sitting there today. We've had no geometry issues, we've had no faults, no twists, obviously, because it's glued in place, but it's a solid slab. And on the right hand side there, you'll see the nozzle. That's the application technology they use. And on the back of the van, see on the back of the lorry, you see the yellow cube. That's the generator that feeds the cube. I did have a picture, but I forgot to put it on, so apologies for that. But on top of the Pro Rail Services trailer there, there's like a great big container with the glue in it and a generator behind it that just spits it out. So we did that. We removed the long-term speed as well. So the speed. So on the left-hand side, you'll see that this comes from the possession planning system. So this basically just tells us where the speed is. So it was over a distance of 25 chain. It was due to soak-click top. And when Lee Binfield was in posting, the asset engineers post, he asked us if we can extend the limits to take it out. we obliged, obviously, because we want to make sure that there's no speeds. We want everything spot on when we hand back. We didn't have to do any updates to the sectional appendix, and we just went in, did it, and it's today. There's been no repeat fault, no anything. So we corrected the formation issue there, installed it, took away that, and I think they save around about 2 minutes per train now. But as you can see from the left hand side, this speed was on for 2 years. So you think in terms of delay minutes per train over the 2 year period, you're talking thousands upon hundred thousands of sort of delays, extra cost, time, all that kind of stuff. But I mean, this is something that as a renewals outfit, we try to incorporate as well. So if there's anything in the area that's causing a problem outside of the renewal limits, we always try to take this inside and try and get things as a betterment, because we're there, we may as well do it. So for signalling, there was a points operating equipment type change to high drive. So this was based on reliability, because high drive on the market is the most reliable PLE you can have. It's really, really good. There's minimal failures, as I'm aware of. We installed 2 new location cases to house the equipment for the high drive. It's quite a big system and requires a lot of sort of like intelligent infrastructure to control and power it. We had to do a lot of troughing alterations to house the additional cables with hard drive. There's a mountain of cables that comes with the equipment. So RCM route control monitoring works were undertaken as well. Conversations with the RCM commissioning engineers happened way before we sort of told them, this is what we're doing. You need to update the intelligent infrastructure, turn off your system at X date, turn it back on with all the recognised new technology we're all in. So we have to do that. It's another process that we have to do as well to make sure the intelligent stuff is updated. So we changed the point detections as well from AC to 50 volt DC within the new location cases for the hard drive. Supplementary detectors were installed on the points as well. That comes part of the hard drive system anyway. We did transformer upgrades due to the POE change. Hard drive draw an incredible amount of power to even switch. They draw so much power. It's incomparable to any other sort of points operating equipment. We installed new disc boxes for the HVIs as well. I don't know if anybody knows about HVIs, bread bins, and sort of like the shock that you can get off it when you're doing maintenance inside of it. So all of the track circuitry around Basingstoke is basically HVI, and we installed new disc boxes so they didn't have to go into the bread bins and they could just go to the disc box and do their maintenance. We did that. I think it was something like 20 track circuits throughout Basingstoke that we did that. So it's a pretty good upgrade for the guys that are on the ground. And installed all new track leads for reliability purposes, because the track leads out there have been out there 20 odd years or whatever. So it's just, yeah, just a perishable that we just replaced anyway. So as part of the hard drive, we had to do a massive power stage. It was really complicated. There was a lot involved in it. You think it's just go and bang a fuse in, but it wasn't, which we'll come on to now in a second. ETM wasn't a lot really. We did 300 foot Conrail renewal. That was it. Rearranged the gap in, made it more efficient. Took out a lot of Conrail that wasn't needed. Rearranged what was there at the moment. We installed 2 new installation track disconnectors to remove hook switches. So those are the grey boxes you see on the side with the switches. They pull it rather than walk out with the short circuit bars and just pull the hook switch open. Sorry, the hook switch bars and close them and open them. So we took that away as well. Points heating, we upgraded to 200 watt per meter strips. Points heating control cubicles were adjusted as well. We installed 1 new PHCC. And we installed 6 10 kVA transformers, replacing the current 5 kVAs, so doubling the power capacity that's available there as well. We did a new bus bar and oscillator as well in the switch room with Barton Mill. Just a few pictures of how it went on. So you see on the left hand side, that's us undertaking the dig. Many machines we used. I think we used 13 separate excavators, dozers, all that kind of stuff just over that junction, all for different purposes, all for different sort of activities within the works itself. On the right hand side, that's us using the Balfour BT Kirov 1200 to install panels. We have to use it because the panels are really heavy, weigh a ton. There's no other way of doing it. They're a trusted partner of us, believe it or not. Balfour BT, they're really good operators for the Kirov. We never really have any issues with them. And this is just in its development. You'll see the diamonds on the left hand side, and you'll see 2521 switch on the right. And this is the power stage. This was out of everything within the S&C renewal. honestly say that this was the most stressful activity that we had to go through as a delivery team to try and do this. So in week 51, so this is sort of 4 weeks prior to the works, we had to undertake a power stage at the PSP at Barton Mill. We had to do it because otherwise we wouldn't have been able to install the hard drive because of the amount of power that was required. PSP, as I mentioned, affected Barton Mill. There were 40 banks of location cases within the actual spread of where these feeders affected. It was 7 miles, one into the other. So it was around about from 41 mile to 48 mile, 49 mile. So the work's undertaken. So for feeder 2, we had 2 fuse upgrades and fuse housings. We had to upgrade it from 63 amp fuse to 100 amp. Feeder 1 and 3 required works up to the 400 volt transformers. So the works are on the solid links. So when you look at solid links, they're basically like pieces of metal that go into the system for continuity. So we had to do that as well. So they're undertaken under A210 testing conditions, which is an arrangement such as like works testing. It's not works testing, but it's a bit lower. So you have works testing G110, A210, SMTH. So we had to do it under that. So this is just talking a little bit about the works extent. So yeah, it was massive. So PWI works obviously very simple. Point heating works simple. Signaling power works huge. It's massive. Yeah, so we're talking, what was it there? So if you look at feeder 2 on the second line of the 650, you had from 48 mile to 49, you had 5110 to 51, 45 to 44. It was just a mountain of work for something so simple. It was just an incredible piece of work that we had to do it in. The problem that we had with doing the power stage is that on the interlocking system, there are 2 data links. You have data link A and data link B. Data link A, which it runs on, data link B, which is fail safe. So if data link A fails, data link B switches straight on. The problem that we encountered when we did some digging is that on data link B, there were 23 TFMs that were out. So the TFMs are the modules that talk to the interlocking. They were out because there was a fault in the FTM, which is the telecoms network. Really, really risky. Nobody could tell us what was going on. We spoke to telecoms. They didn't know. They were out there for 3 or 4 weeks trying to diagnose the problem, and it got to the point where we've just got to do it. We've got to do it and just try and be as risk averse as we could. So again, countless conversations with telecoms to try and fix it before the power stage. We had no support from the local Basingstoke S&C. We asked them for TOs, they couldn't supply, and it was usual stuff that we encounter. And yeah, basically, if both of the links failed, it was a complete and total blackout for 7 miles of signalling. So you can probably imagine what that would have done. It would have been code black up at the incident control. Everybody's screaming, what's going on? So the process of works, we had to come up with this process. So 1 feeder at a time, do the work on feeder 2, turn it back on, make sure the intelligent infrastructure worked, make sure all of it was recognised. Then feeder 1, do it again, same process. Feeder 3, do it again, same process. And the problem with SSI, which is like solid state interlocking, the conditions that you turn the interlocking off in, they have to remain the same. So as soon as you turn it off, there's no wheels on, you have to turn it on within those extents with no wheels on or no changes. If there's any changes, it throws a wobbly and it doesn't like it, and you have to go and physically find the fault within the 7 miles. It was quite daunting to do, to be fair. And it's part of the operational requirements as well. As I mentioned there, no wheels to be moved. And we actually put something within the one itself. So operational requirements for our DP work. So all wheels to be stationary throughout. No other works to be linked. Wheel free required until 1000 hours Sunday. So the actual works itself took 8 hours. The contingency that we had spare TFMs on site. I mean, me and Paul had a conversation before we came in. There were sort of like 40 TFMs on the data link, and they wanted 40 spares on site. They're 10 grand a pop. So you can imagine £400,000 worth of spare equipment that you're never going to use. Seemed like a waste. So we managed to find some from some of our colleagues, our very nice colleagues over in Kent and Sussex. So they helped us out. So we were pulling them out of Croydon, pulling them out of Ashford, but we got as many as we could. And what we did was, we'll come on to the schematics in a minute, but there was obviously over 40 location cases. We had one mod 3B, which is the S&T guy. We said, right, you cover log 1 to 6. Yeah, if there's a failure, they know it's on that log, you can go in and check it. So we had that throughout the whole process. So we had a whole map told them all where the location cases were. We drew it on a map for them, showed them, wrote a process for them. It's quite complicated. It took a lot of doing it, sort of like briefing after briefing, making sure it's like drummed into people. We booked intelligent infrastructure support, a guy called Connor Clements, who's sort of the go-to guy for I. He couldn't have helped us anymore. He was absolutely brilliant. So I took off coming on a Saturday night when he had annual leave booked and said, yeah, I'll help you, no problem. So we were happy with that. But yeah, it was a great help. Staffing has been provided to cover any failure that may occur. As I said, we've mapped it out. We had people on X amount of location cases just in case. And point 4, just reiterating the point there, the map location case has been created against the access points. So wherever the location cases were, we sort of said, well, your access point for that location case is there. That one's for there. But we draw it all out. It was quite a big piece of work to do that in itself. And that was just done so we didn't have sort of like one mod 3B or one tech walking sort of a mile down the track. So he could be where he needed to be at that time to get it back online as quick as he could. And if required, although I said that we didn't have any help from bases, though, we had the option to call the 14, but we had to go through the incident control for that. So it's kind of like usual stuff for us. So just a graphical representation of the feeder schematics. So this was what was affected on feeder 1. Each of the individual rectangular boxes constitutes a loc within the system on that feeder. Feeder 1 wasn't too bad. Feeder 2, yeah, worst one. This was the biggie. And this feeder was the one that needed the most work. So yeah, we are kind of lucked out with that one. And feeder 3. So those are just location cases identified in the feeder schematics. We drew that up and sort of cut it. Everybody digested it. Everybody lived it for about 2 weeks. Everybody knew exactly what they were doing. Just going back to that one, although we had 10 hours to do the work, we were really lucky. It took us 3. So to do all that work took us 3 hours. We didn't have a single hitch. It went as smooth as it possibly could. We had absolutely not one problem at all. Everybody was just on their A game for that one. It was one of those things, if we didn't do it, we wouldn't have had a renewal. And this is just a couple of pictures of sort of, well, this is me delivering on the left-hand side, taking delivery of S&C panels in the snow. That was really nice. Nice and warm. Stood down at Basingstoke upsidings, taking that. So the areas you see on the left-hand side is where we delivered all the S&C panels. So they all just came there. We had them all stacked up in the correct methodology, so we can go pick one up, come back, pick the next one up. So there was no messing about. We had a decking diagram which showed in this pile you'll have panel 573 or whatever. We had that as well, so that helped us. And on the right hand side, it's just a little bit of a picture showing us doing a bit of tamping and a bit of topstone in the final assembly in. So that was Basingstoke in a nutshell, and this slide just goes into some of the stuff that I'm working on as an S&C PM. So for the remainder of the control period, I'm looking at Wokingham. So that's all changed from mechanical interlocking. That's been re-signalled now by the Feltham re-signalling team. So I'll go in there, do the track ETE negative bonding from in week 46. Staines S&C happens at the end of the year, going into the new year. Millbrook, which is the S&C renewal that I showed you with the drainage problem. There's that. Brookwood, Port Creek.
Best of luck with that one.
Port Creek. Well, you can see my comment there. This project is the stuff nightmares are made of. So it's got a really horrible interlocking system, SIMIS. Only the maintenance can test it. Only the maintenance know how it works. No contractor knows how it works. As well as that, it goes straight onto a viaduct.
It works out we needed to slew it.
Yeah, that's RA0, so we can't even put an engineering trainer on it at the moment. So as part of that parcel of work, we've now extended the block by 4 days, and we've got a structures team coming in and shoring it up to bring it up to RA8, where we can actually physically work. And off the back of the interlocking, as NR, we're developing a training course for contractors so they can actually come in and do the works testing on it, which is going pretty well, to be fair. So there's a lot.
Been done 15 years ago.
Yeah. But it will get done this time. Queenstown Road S&C CP7 adjacent to 9 Elms where the wall fell down. Unfortunately, I was the project manager for that one. Yeah, that was fun. I know Steve Roach on the call. Steve was up there with us as well. Reading Spur CP7 Woking Junction, which is a biggie as well. That's kind of got the same issues as what Basingstoke has in terms of failures. And Q Junction, but that's just a little bit about what we're doing sort of for the next 5 years as well, amongst a myriad of enhancements and probably 100 plain long renewals as well, which don't really get talked a lot about. And that's it. So I'll hand over, and if anybody's got any questions, I'm happy to take them.
Thank you very much, Kevin. Let's start with questions in the room. Would anybody like to ask a question in the room? Yes, Jim.
Could you hazard a guess at the cost of the administration of all that before you even buy a piece of kit in relation to the actual cost of buying the kit, putting it in?
In terms of sort of like AFC, it's sort of like it's like actual cost throughout the whole project life cycle.
Well, more a ratio, if you like. I'm happy with a ratio.
So in terms of unit rate, which is what we work on as a deliverer, this was the most expensive S&C renewal for the whole control period. It was something like, I think it was like £2 million an end. It was a lot of money, but there was a lot of work that happened in it. In terms of whole life costs, from start to finish, I hazard a guess at around about 8. There's 8 million. There's a big piece of work.
What's the root cause of the restriction over the upfast there?
Cyclic top.
So,
Cyclic top had poor formation.
yeah,
We talk about speed restriction, yeah.
yeah.
So there was just a long-term formation issue. It's just substandard.
Was it anything to do with the construction of the castings? Because I've seen Simpson presenting on this years ago about how they were so poorly designed for RT6.
Cyclic top in a plain line, okay?
Cyclic top was in the plain line in terms of the RT60. So RT60s ran out for concrete cancer. So yeah, so the bearers is on there ran out for concrete cancer. So if you look at the bearer longitudinally throughout the sleeper, it just broke out. We had the same issue at Eastleigh. I don't know if anybody remembers the Eastleigh derailment that we had across the S&C a few years ago. That was RT60 as well. So we had the same issue there. So it's a repeat failure. It's kind of like the same thing happens every time. Down at Eastleigh South, they've actually banned using it. So they can't actually, they've sort of taken it out of use. So that operationally it doesn't help, but yeah, they've done that.
So just following up on that. So there were housing failures, weren't there, at the point ends?
Yeah.
On the down slow and the up fast. I can't remember the point numbers. But do you know whether the housing design in the new installation has changed? Because there was a design.
It's NR60 now. It's NR60 Mark II. So rather than being NR56V, it's NR60. It was N60 with RT60, but it's NR60 as a sort of setup is better. It's more involved. It's been designed better. It's been tested to death. And not only that, for bays, it's like we flattened the junction out as well. So as the train's coming round, either going up the BKE, which is the line that goes round to Reading, and as it comes down, it was mainly caused by freight. So as the weight shifted, it was sort of throwing the junction out. Paul, was that correct? It was causing the junction to shift, wasn't it?
Correct.
So we flattened out. So instead of having such a severe curve going through it, it's got a smoother transition. Not to say it's perfect, but it's the best that we could have possibly got with it.
Actually worked out how it's quite an achievement considering the geometry comes in from the UK.
But the entire track moved by an entire gauge. So if you look at, if I go back to, bear with me a second, I'll find a picture. I think it's right at the start. So if you look, can you see where the signal box is? See where the orange GRP fence is? So we had to restrict the walkway. So we took a whole gauge of that corner out, and the BKE essentially moved. It moved towards the signal box, and the toes of the points actually moved towards the signal box as well. So it's a smoother transition into that curve.
So is it perfectly straight on the two main lines there? Is it perfectly straight through the diamonds?
Yeah.
Right.
There's no humps and bumps or dog legs or anything. It's as straight as it can be.
Did you move it towards the box so you could curve it back and get flatter diamonds?
Yeah, we took it from a 1 in 4 to 1 in 5.
Yeah.
So then we trimmed, like I said, we trimmed the whole gauge off. We had to sort out the walkway for the drivers as well. So effectively, if you had, say that was the junction with the signal box here, it went from here to here. So everything just shifted, and it just made it better. And when we put it through modelling, it worked out. It was better. And we haven't had a problem yet. And it's been in for what we now November. It's been in 7 months, and we haven't had an issue with it, as far as I'm aware.
In view of the fact that the up slow and the turnout to Reading is the heavy freight route in that direction, Was any consideration given to changing it from a 25-mile-an-hour turnout to something rather faster?
The problem you've got with that is it's all done, it's all to do with sort of like network change and that as well, isn't it? So it's like the design for that, I think the design for the actual turnout itself was a maximum of 30 mile an hour, but that was just because of the way it was designed. There was no, it's all to do with sort of like rate of change, cant and all that sort of stuff, and how severe the curve was going around there as well. So they did look into it from the start of it, but they decided not to change it. I mean, we looked at a reduction in speed at one point as well, but we have to go through a whole process where we have to consult the operators as well. And they didn't want it. They wanted the same speed profile going through it. It's, if you do anything in terms of changing speeds, it's a huge undertaking to do for any project.
Yes, it's reasonably compliant as you go around the PKEs as well. Once you get over to
Yeah.
S&C, it's
You're straight into a reverse curve anyway, there, aren't you? You're going around the PKEs.
Can't remember where does the speed increase beyond that S&C?
It's beyond the bridge. It goes up to the bridge, doesn't it? With the bridge,
Yeah.
I think that's the change in speed there.
And is it 90 miles an hour then through the junction on the mains now?
As far as I'm aware, yeah, it is. So I can go back to the section appendix.
There's the upside of 65, I think.
There you go, 90 and 100. So it increases to 100 once you get up past the S&C.
is it quite challenging to do the, it might be, was it quite challenging to deliver those units when you're confined within
Yeah.
other S&C units that you're not touching? I know you,
Yeah, it was, yeah.
Weybridge sort of similar, but there can't be too many occasions to try and fit in a complete renewal but still be pinned in within the alignment of other S&C around you.
So we amended the alignment anyway, didn't we? So when we went through and actually physically placed it, so we adjusted the alignment to an extent. But the hardest bit was actually making diamonds fit when we landed them. It was a nightmare. It was, I mean, it's such a complicated layout for what it is. I think it was only something like 11 S&C panels in total for it. It's small, but it's really challenging because you've got to just be mindful of where everything sits. Because you've got to make, I mean, you've got 2 lines over. You've got to make sure where you're putting it matches the geometry profile for it. Because if you didn't land it right, you would have been in a world of pain. You would have never got it.
Do you have to follow anything different in terms of fixing your alignment, in terms of checking the alignment going in, or is it just being extra cautious with the approach that you take?
Just being really cautious, really. So, I mean, obviously we have a tamping scheme, don't we?
Mm.
So with the XMLs and all that kind of stuff, obviously they're checked and vetted and like proved and all that kind of stuff. But yeah, we didn't have too many problems with the install itself. It went quite smoothly. It was just actually getting to that point. It was harder getting to the point of delivery than what it was actually delivering the renewal itself, because of all the red tape and all the hoops we had to jump through, and all the making sure that we got rid of all the non-compliances that were there, and dealing with sort of outside parties that, like I touched on, dealing with ASLEF or walkways. I know it only sounds silly, but it's a big thing to them, and it took a lot of people's time. This was probably, in terms of requirements, like what everybody wanted here, it's probably one of the most challenging renewals I've delivered since I've been doing renewals. We had to make everybody happy, or try to.
Blue ballast, has that been around long and it's very expensive, is it?
Yeah.
How do eventually you've got to break it out? I mean, it's obviously it's not like concrete, but
So with Hurliman, believe it or not, if you pour hot water on it, it dissolves. So we had an issue where the Romberg Sursa went out there and we said to him, don't glue the cables into the ballast shoulders. Make sure you, so they were supposed to wrap them in cling film so the glue didn't stick to them. I know it sounds strange just using a cling film, but it works. They had to go back and had to pour hot water over the cables to pull the cables back out. So it's anything over any I think it's 8 degrees the water temperature, then it sort of melts the resin. I think that's what they said. It's a high temperature, but we used to use Railtech glue, didn't we? I can't remember what it's called. It's just Railtech glue, and that literally did that. The penetration of it wasn't nowhere near this. But this is like, now this junction's glued. It's glued. It's not moving anywhere.
Some of the glue is just on the shoulder.
It's 400 mil wide, 450 mil deep on the shoulder.
Isn't it? So the middle can still respond to vertical tapping.
Yeah.
Yeah.
So you can lift it. You can't stir it.
You've got a beam down each side as before.
Yeah.
Yeah.
And obviously you've got to be careful of the switch toes and all that stuff as well, because you don't want ballast going to get on switch toes because you'll never be able to move them. So there was a lot of care and attention that went through for sort of getting that prepped. The sheer amount of cable that's out there at Bases, like with all the track circuits, electrification, posies, neggies, all that stuff, they had sort of 2 weekends where they were just going around wrapping cables. So there was a big piece of work in itself to do that.
How long ago was this?
7 months.
7 months.
So this was done at Easter.
How's the top holding up?
Hasn't moved. We've had no issues with any notifications from the track recording train. I mean, our TGA, which is our track geometry acceptance certificates, look good. So we've got all that. It hasn't done anything. So the bad formation that was there, we've taken it away and we've given it some really like hard hitting stuff. It's up to the job.
Did you put on about pads on?
Yes.
Okay.
Yeah.
We put it on over the dials and see it resolved.
Yeah.
Differently as a result, Scotland. Yes, well, we have less players. Yeah.
So underbarrel pads went on the S&C and underbarrel pads went on the plain line as well. Yeah.
Are they the same thickness?
Yeah.
Across all the bearers?
Yeah, so for plain line, they're called SLB 3700Gs. I can't remember what they're called for bearers. They're different types for different bearers. But yeah, no, they're all the same. Because you used to be able to just get glue and stick the pads on, but you can't anymore. So when they cast it, they physically cast the pad into the concrete now. Yeah.
Well, it's Velcro, isn't it? Little tails that sink into
Yeah.
the concrete.
It's got little hairs that go into the castings.
Does the underbarrel pad go the whole length of the pad? Sorry, the whole length of the
Whole
pad.
length for the barrel. Whole length for the barrel, whole length for the sleeper.
Is that standard for NR60 Mark II?
It's standard, whatever you use. I mean, you can get NR 56 layouts with underbarrel pads on,
Yeah,
but it goes the full length because
I seem to remember we specified it as a standard for when we developed that.
I haven't seen a sleeper with just one on the corners.
No.
Have you fitted them on, in recent times, you've fitted them on all your S&C?
Yes. Yep. So it's a requirement. It's a requirement as a minimum that for S&C underbarrel pads go on, just because it improves the rigidity.
We're going to get that stain somewhere.
We do it on a lot of plain line as well. So for Cat 1 and 2 track, we do underbarrel pads, under sleeper pads, shall I say? We do that as a standard now.
It puts back the resilience in that we used to have, doesn't it?
Yeah.
Sleepers.
So broadly speaking, what's the change in the cost of a bearer with or without a pad?
I couldn't tell you what the difference in cost was. It's not massive, but it's still obviously quantifiable against whole life of project. But it's the benefit. I mean, the benefit outweighs the cost at some point. I mean, especially somewhere like here, knowing how many failures, how many problems. Look, I can tell you how many times this junction failed. Do you know, Paul? Before we went in and did it.
I know you have a lot of issues. By memory, you'll see tie bars and missed sleeves.
Yeah.
That's my issue because it was converted on that route, pretty much converted over to that mitigation about 3 months before Easter happened, something like that.
Yeah.
3-4 months before Easter happened. When the team at the time, Alex, saw a lot of failed housings. From my side, the relief of that while going out and doing a verification and finding more failed housings that inspectors hadn't managed to spot because of time limitations on the inspections at that time. That's been rectified, but peace of mind that gives me in terms of the problems that was the most visible problem that we had with failed housings. It's obvious that there were problems with that constant regular freight usage going on a pretty tight curvature.
Yeah. So we don't interlace bearers anymore as a standard.
Yeah.
We avoid it.
It was just a
Like the
mitigation.
plague.
Kevin at the time, we just needed to do something to keep it running. It just looked like a fantastic painting when you posted pictures for it. All that's what I was saying. So keen to see compared to what a dog's dinner it had been, because just trying to keep the thing running beforehand, it's a fantastic solution.
Yep.
Well, we got any questions on the?
We haven't, no. We've got a couple of technical updates from Mr. Alan Cowans saying there is a totally different fastening systems on NR60 Mark II to the Alpha Beat ER260. Secondly, he said that the turnout, I presume he means on the up main, the turnout was shortened from a D to a C switch.
Yeah.
On the up slow, sorry.
Yeah. So we installed 2 Cs here. 2 Cs with high drive.
Does Alan know specifically?
Alan was the DPE.
Yeah, he's online, is he?
Yeah. I think
Does
so.
Alan, do you know specifically how many dowels there are per base plate in the NR60 design? Because there's only one, wasn't there, on the and on the RT60?
What for each, it's like cast housing. wasn't it?
Yeah, exactly. Yeah.
So say that again, Andy. I'm not sure I followed what you're asking.
All right. So how many dowels are holding the base plates in place on NR60?
So it's not as straightforward as that. So there's parts of the layout are on base plates, part of them are like direct fastening. So I'd have to get the drawing up really and go through it. But there's about, I think there's 3 or 4 different ways that rail's fastened to the bearers through the Mark II layout.
Yeah.
That's probably. I mean, you could probably have a whole nother meeting going over that, to be honest, Andy.
Yeah, there's Alan, there's probably 4 or 5 different sort of torque measurements as well for the fastenings, isn't there?
Yeah,
So
they've all got to be properly torqued. There's slightly different fastenings, and it gets quite complicated. I've got some good stuff that we used to distribute in the central region when I worked on there for our people who were installing this stuff, like toolbox torques. I was trying to put the design for this layout in the chat as well, but I can't. It doesn't let you. So unfortunately, you haven't been able to do that. But yeah, there's lots of differences, especially between the NR60 Mark II and the old Bound 4B stuff that came out of there, which was like radically different.
So the fastening system is called an SKL system on NR60 Mark II. Don't use fast clip or pan draw, it's SKLs. So they're sort of they're winged clips, Alan, aren't they, with screws and wedges
The
and
possible fastening systems
Yeah.
At various different sizes depending on whereabouts in the layout they are. Whereas the Bound 4B was all integral castings, quite raised above the level of the concrete, and you had like various base plates that slid over those that were then clipped in with a pan roll clip.
Yeah.
So we had to I remember the first time we did, Alan, we physically had to get someone down from Vosloo to show us how to do it. It was that complicated because you've got pads, wedges, you've got clips, you've got screws, and it's sort of like if you put one the wrong way, then it compromises the fastening.
Yeah, and it's quite critical that it's all installed correctly as well, especially when it's not on base plates. When it's hooking, you've got like T-bolts and things like that. They've all got to be vertical. The clips have got to be properly installed. These lead to, if they're not properly installed, they lead to pretty significant failure modes later on.
Maintainability then.
In terms of maintainability, so when we actually installed this, so we did this set up at Farnborough beforehand. So we gave all the training to the Basingstoke team. We gave them all the tools and equipment to do it, all the cups, everything. They get 10% spare clips, 10% spare pads, 10% spare wedges. So they had a bursary really. I think one of the Lossomat guns, when it first came out, we had to get them from Warlift, and I think they were like £5,000 each. So they're bloody expensive.
That's for tightening fastenings.
So yeah, so you can't use a band, you have to use something called a Lossomat, which is, if you imagine a drill, it's got a cup, like a Vosloo cup on the end of it, and it's got an arm. So as you tighten it up, once the arm touches, you can't tighten up anymore, and you set the torque setting on the gun, and you can't go any further than that. It physically won't allow you. But if you do it with a band, Alan, it cracks a bearer, doesn't it?
The problem with the bands is it's got no torque control, so you can over tighten. So obviously people just go crazy on them. They don't realise how tight the things are.
And doing it, like, if we catch anybody on site, it's an absolute no-no.
And basically, PWI have got one of these now.
They've got 2 of them. They've got 2 of the kits. They got a full set of cups. They got all the clips, pads, and everything. They had somebody come down from Vosloo to teach them how to do it, and we had training panels in Basingstoke when we did Farnborough. If you remember, Paul. Bought a training panel down, so everybody sort of in the room could come and have a play on it and work out how they do it.
This beforehand to train the maintainer up on all the new stuff that we've ended up giving them. But
we have to now. If we don't do it, we get a slapped wrist.
You do wonder if it behaves itself for 10 years and then it starts going wrong.
Yeah.
A lot of those people will then have moved on, won't they? You do wonder whether they've got the knowledge to keep maintaining it.
But yeah, they've got the tools and the kits they need to do it. They've got all the fishtail, everything they need, everything.
Did it come with a little handbook or anything like that? Or?
No, No, so we had, I think,
or an online page or anything like that?
so we had to get someone physically down from Voslo that created the assembly to come and teach us how to do it. They come down with a presentation. I've got the presentation somewhere. I'll have to dig it out and send it to you, Paul. But they physically had to come down with they come down with a piece of rail with like a fastening on it. And they showed you how to put it in, what torque measurements you had to do, took you through a presentation. It's kind of like you see, you do sort of a setup. But yeah, we had to go through all of that because I mean we before Basingstoke, when we did Farnborough, which is I think 2 years beforehand, we did the first one other than the troll site, which was up north. I can't remember what the place was called, but it was the first one that had been put into sort of like a mainline setting. Alan, I don't know if you know the name of the troll site before they sent it out. Do you remember it beginning with a U?
Ulsterby.
Might have been Ulsterby.
I don't know, it might be that.
But yeah, they did that. Then we were the guinea pigs for it because Mr. Norcutt wanted it. So yeah, so it was a big learning curve. But I mean, we're still learning on it now. The stress is different, Alan, isn't it? It's effectively ball and claw.
Yeah, so it's stressed in the same way as ball and claw, but they've got this like alignment holes off the tips in that way, instead of the line and ball and claw and setting the ball and claw setting. You're supposed to stress the stock rails and then just position the switch tips accordingly based on these alignment holes.
So that was another one for us as well, getting used to how to stress it. But I mean, basically, we had a few issues with the stressing, Alan, didn't we? With contractors saying we don't need to stress that, and then Alan proving them wrong, and yeah, so we went with that.
All good fun in it.
Yeah, but that was part of the project as well. But that was Basingstoke.
We've run out of time.
It's all been fascinating.
I mean, to be honest, I'd like to listen to an entire talk on the stress design and installation.
Alan's your man for that.
Perhaps Alan, you could do that for us and tell us a little bit more about the NR60 design.
Lived and breathed that, Alan, didn't you, for 6 months? So
It's fantastic. Well, thank you very much indeed, Kevin, for coming here, and thank you very much, Alan, for your little interjections online as well.
No worries. Sorry for stealing your thunder, Kev.
that's right, mate. I'd rather have you there than be thrown to the wolves.
So thanks very much for spending the time here this evening explaining
No worries.
what was a very big part of your life last year, by the sound of it. And what strikes me with quite a lot of these renewals presentations is how much work there is involved that is not PWI related as such, to do with electrics and signalling, and sometimes feels as a PWI person that perhaps, and no offence meant here, that we blunder into those a little bit, and I wonder if there's anything that we can do to sort of smooth the path of that, because it's you guys, once you're actually in the delivery phases, that are picking up some of those difficulties, I guess, rather later than you would like to, and of course that just adds to the additional study jobs.
Yeah.
But thank you very much indeed
No
for
problem.
tonight's presentation, and I'd like us to give you a round of applause. And I think one of the advantages of coming here tonight is that we get to go to Wetherspoon.
Yes.
Yes.
Recommended post-meeting analysis.
Right. So,
You're
you're very welcome to come along and join us down at Wetherspoons if you've got the time. Thank you very much.
Yes, definitely. I love that. Come on, let's do it.